You mentioned something before that I wanted to kind of drill down on. You mentioned how LLMs maybe are not the right model. Diffusion models are maybe better for voice or
autoregressive models.
Yeah. So say more there, because everyone, when they think about AI right now, they're all focused in mostly on LLMs. Obviously on imagery, diffusion models have been used, but why voice do you think diffusion could be a better solution than?
Well, first off, what's great about diffusion models is it can be multimodal. I mean, so are your autoregressive models, but what they're doing is they're adding actually a diffusion header to it, right? Because you're able to put in the whole spectrogram into that model. But let's just take that out for a second. I think the thing to think about here is that an autoregressive model thinks from left to right, where a diffusion model thinks left to right and then back left again. So it can go back and forth, and it creates a frequency. And that's how it's able to land on its answer that it's looking for. We know that technology is still lacking in a sense because it came out far afterwards. And everybody's been chasing, I guess you could say, the dragon on the LLM side for autoregressive models.
I think it's important to point out that when he says a diffusion model, he's actually talking about a diffusion model for LLMs.
Correct.
Because that's the key architecture here, is that we know diffusion models work for images and videos, but now there's a lot of engineering and science that's being done and research into these diffusion models as LLMs, and it's a perfect application for voice because of latency.
So think about it. A diffusion model, the difference between the two, to fully understand it, is in a general LLM that you're using with ChatGPT, it's predicting the next token, right? Mm-hmm. It's predicting the next word in the sentence. Where in a diffusion model, it's actually predicting a paragraph or two paragraphs. So that is extremely useful, right? Because what if we took some of that information that it's predicting at the same speed and gave it to reasoning? Oh my God, we just created the first voice reasoning model.
And I could put it into perspective for you why that's so groundbreaking for voice. If you look at the voice tech stack and you look at you break the latency per part of the stack, the LLM takes up between 60 to 80% of the stack's latency. So if you can solve that with diffusion, you can drop your overall latency to probably under half of what you're currently having.
And you don't need a 1 trillion or 10 trillion parameter model like Mythos to have a good voice model. Actually, matter of fact, you just need a really good model that fits in the right parameters, that's able to take good instruct. That we find that to be a far better solution. So when you start to talk about this, we don't need to develop a 1 trillion parameter model that's great at coding, that's great at general knowledge and history and all these other features. We just want it to be great at just conversation.